this video, we're going to discuss about the open sets in the set of real number. Pero bago tayo magsimula sa definition ng open set, so I want to define first the definition of epsilon neighborhood of a certain point. Okay? So dito muna tayo. Let C be any element of the set of real numbers and let epsilon be greater than 0. So we define the epsilon neighborhood about C denoted by this symbol, read as the epsilon neighborhood of C or epsilon neighborhood about C, to be the set epsilon neighborhood about C is equal to the set containing X such that the distance between X and C must be smaller than epsilon. So we call C the center of the neighborhood. So ano ba yung sinasabi nung epsilon neighborhood ng C ng isang point? So yung epsilon neighborhood, yan yung kumbaga pinaka representation ng mga values na malapit or closer sa certain point, let's say C. So kumbaga ang tinutukoy natin dito yung mga values na malalapit sa C. Tinuturing natin closer sa C. Okay? Now take note of this. From the absolute value of x minus c less than epsilon, this is equivalent with x minus c greater than negative epsilon less than epsilon kung i-apply mo yung property na absolute value, and this is also equivalent to x less than c plus epsilon greater than c minus epsilon kung magpa-plus ka ng c sa both sides. Then this is also equivalent to x element of the open interval c minus epsilon comma c plus epsilon. Okay? Now, napakahalaga kasi nito kasi ito yung madalas natin ginagamit para ipakita yung epsilon neighborhood ng C. For illustration, so let's say meron tayong real number line. By the way, naka-focus lang tayo dito sa real number line based sa definition. Then, let's say meron tayong interval dito. Let's say A, B. Okay. Then, meron tayong point C dito. Then, yung epsilon neighborhood ng C, eto siya. So, yung mga values na to, ito yung mga elements ng epsilon neighborhood of C. So, this is the epsilon neighborhood of C. Yung mga values na to, ito yung mga values na tinuturing natin closer sa C. Okay? So, para maintindihan natin, let's have example. The one neighborhood about 0 is the open interval negative 1, 1. So, kung titignan natin yung itsura niya, let's say ito yung point 0. So, yung 1 neighborhood niya will be negative 1 tapos 1. Yung open interval na to. Okay? Yan yung 1 neighborhood of 0. So, meaning, yung mga, kumbaga, sa word na rin na neighborhood, no, yung mga kapitbahay na values ng 0 ay yung mga values dito na hindi, na less than or equal sa, greater than or equal sa negative 1, but less than or equal sa 1. Okay? So, ibig sabihin, yung 1/2, masasabi nating neighborhood siya ng 0. So, yung 1/2 na to ay element ng negative 1, 1. Okay? Kumbaga, 1 neighborhood siya ng 0. Pero, yung 3/2, hindi siya 1 neighborhood ng 0. Negative 1, 1. Okay? Kasi, yung 3/2, somewhere yan dito. So, wala siya sa loob ng open interval. Okay? To generalize, let epsilon be greater than 0. Then, yung epsilon neighborhood about 0 is the interval negative epsilon, epsilon. Okay? Or 0 minus epsilon, 0 plus epsilon. So, ganun lang kasimple yung idea ng epsilon neighborhood. So gagamitin natin yung idea na yan para sa definition ng open sets. Okay, for definition ng open set, let O be any subset of the set of real numbers. We say that O is open if for any C element of O, there must exist an epsilon, positive epsilon, such that the epsilon neighborhood of that point, that C, must be a subset of O. Okay? So, ibig sabihin, masasabi nating open ang isang set kapag lahat ng values doon sa loob ng set na yon merong mag-e-exist, sa lahat ng values na yun may mag-e-exist na epsilon or makakabuo tayo ng epsilon neighborhood sa bawat values na yon na subset ng O. Okay? Pag sinabing subset, ibig sabihin, yung lahat ng elements ng epsilon neighborhood ng C ay elements din ng O. Okay? In short, wala tayo dapat makikitang values neto na wala sa element ni O para masabi natin na open ang isang set. So, let's have example. Okay, for examples, magbibigay ako ng tatlong examples para dito. Number 1, show that the set of real numbers is open. So, para mapakita natin na open ang set of real numbers, dapat sa lahat ng elements ng set of real numbers, makakabuo tayo ng epsilon neighborhood ng element na yon na for any epsilon for any arbitrary epsilon, na yung epsilon neighborhood na yon dapat ay subset ng set of real numbers. Okay? So, for our proof, mabilis lang ang proof nito. So, given any positive epsilon and let C be any element of real numbers, then yung epsilon neighborhood ng C, which is equal to C minus epsilon, C plus epsilon, okay? Then, by property of real numbers, since epsilon ay real number, positive real number, and yung C ay element ng real number, kapag nag-minus ka ng two real numbers ay palaging real number pa rin yan. Ganun din, kapag nag-plus ka ng dalawang real numbers ay real number din. Then, sigurado tayo na yung interval na to ay subset ng real numbers, set of real numbers. Okay? So, therefore, the set of real number is open. Okay? Next, number 2, show that the empty set is open. Okay? So, for our proof, again, sa definition ng open set, dapat lahat ng elements ng isang set makakapag-produce tayo ng epsilon neighborhood na subset nung set na yon. Okay? But dito, sa empty set, wala siyang element. So, meaning, since empty set has no element, it vacuously satisfy the definition. So, ano ibig sabihin nung vacuously? Ibig sabihin, yung hypothesis natin, kumbaga, kung meron tayong implication, so yung premise natin implies kahit ano yung conclusion na yan, basta yung premise natin hindi na natin na-satisfy, sigurado tayo na logically equivalent sa one na yan. Okay? Kumbaga, yung statement na yan ay kino-consider na kagad natin na true. Although hindi natin alam yung conclusion, basta wala na siya nung zero na siya dun sa hypothesis, so ko-consider na natin na tama yung statement na yan. So parang dito, dapat dun sa hypothesis, para masabi natin na open, dapat ay may element. Okay? Pero dito wala siyang element. So it vacuously satisfies the definition. So we can say that empty set is open. Okay, by the way, nakalimutan ko pala to. Now, for example number 3, show that any open interval AB is open. Okay? So, for our proof, let C be element of open interval A, B. So, bago tayo mag-proceed sa proof, pakita muna natin yung itsura niya for motivation. So, let's have the real number line. Tapos, meron tayong open interval AB. Then, meron tayong element nito, which is point C. Then, take note that point C is an arbitrary element of the open interval AB. So, pinakita ko lang na nandito siya, pero kahit saan siya dito, yung nire-represent niya. Okay? So, dapat ang goal natin dito, dapat makapag-provide tayo ng open interval centered at C. So, ibig sabihin, yung epsilon neighborhood ng C, which is yung open interval na yon ay dapat subset ng A, B. Open interval A, B. Okay? So, what to show, para magawa natin yon, dapat makapag-provide tayo ng epsilon such that the epsilon neighborhood of C is equal to C minus epsilon, C plus epsilon, subset ng A, B, open interval A, B. So, ito yung goal natin para ma-prove natin na yung open interval AB is open. Okay? Now, iset natin yung epsilon to be the half of the minimum ng distance ng A and C. So, C minus A, and distance ng B and C. So, let's say B minus C. Okay? So, bakit minimum pa neto? Okay, 'di ba mas malapit tong AC? Katulad ng sinabi ko kanina, hindi yung point na to ay arbitrary. So, pwedeng nandito siya, which is yung minimum niya ay yung C minus A. Pero, pwede rin nandito yung point, which is ang minimum naman ay B minus C. Okay? So, kaya ang ginawa natin, basta kunin natin yung minimum niyan, tapos, kalahatiin pa natin. So, yun yung ating magiging epsilon. Okay? Now, let X be element of epsilon neighborhood ng C. Okay? This implies X element of C minus epsilon, C plus epsilon. So, take note tayo, epsilon natin, ito yon. Okay? And this implies C minus epsilon less than X less than C plus epsilon. Okay? So, diniscuss ko yan kanina. And this is also implies, take note ha, yung epsilon natin ay kalahati ng minimum nito. Okay? So, ibig sabihin, yung C plus A minus C, okay? So, antong A minus C? Kung ang C minus A, which is ito, ay positive, malamang yung A minus C, negative yan. So, ibig sabihin, parang binawasan mo ng C minus A yung C. Ito, yung value ng C. Is less than C minus epsilon. Tama? Mas mababa to dito sa C minus epsilon. So, paano mo nasabing mas mababa? Kasi ang epsilon ay kalahati lang nito. Pero ang A minus C, syempre, or yung C minus A, yung positive, mas malaki siya sa epsilon. Okay? Kumbaga dito, mas malaki yung binawas natin sa C kung ikukumpara natin dito na mas maliit yung binawas natin sa C. Kasi ang binawas natin sa C dito ay kalahati lang nito. Okay? And this is less than X. This is also less than C plus epsilon. And this is less than C plus B minus C. Okay? So, bakit naman naging greater than to? Okay? Kasi yung B minus C natin, which is ito, mas malaki kumpara sa ating epsilon. Okay? Kaya dito, kung nag-add ka lang ng epsilon sa C, mas malaki yung nag-add ka ng B minus C sa C. Okay? So, nasundan? And then, this implies C plus A minus C, that is A less than X less than C plus B minus C magiging B. So less than B. Okay? Or this implies X element of A, B. And as you can see, if X is element of the epsilon neighborhood of C, this implies that X ay element ng open interval AB. So this shows that the epsilon neighborhood of C is a subset of the open interval AB. So therefore, the open interval AB is open. And we are done. Now let's have two important theorems about open set. So letter A, the union of a countable collection of open sets is an open set. And for letter B, the intersection of a finite collection of open sets is an open set. So ipoprove natin yan. So let's start with letter A. Okay, let's prove the first theorem. The union of countable collection of open sets is an open set. So for our proof, let the set containing O sub 1, O sub 2, O sub 3 be a countable collection of open sets. So, ibig sabihin yung O sub 1, open set yan. Yung O sub 2, open set yan. And so on. Lahat ng elements dito ay open set. Okay? And let O be equal to the generalized union of O sub n from 1 to infinity. So, ibig sabihin daw, kapag pinag-union mo lahat ng set na ito, ang lalabas ay O equal sa O. Tapos, ang goal natin, dapat mapakita natin na yung O na to, which is union ng lahat ng sets na to, ay open. So, we have to show that O is open. Okay? So, una, if yung O ay empty set, then O is already open. So, na-prove na natin yan na kapag empty set, open yan. Okay? Kaya, doon tayo sa non-empty set. So, if ilet natin na yung O ay non-empty set. And let C, so ibig sabihin may element yan kasi non-empty set, be element of O. So, ang goal natin, dapat makapag-provide tayo o makapag-produce tayo ng positive epsilon. So, we need to provide positive epsilon such that the epsilon neighborhood of C or about C must be a subset of O. Para masabi natin na yung O ay open. Take note yung C ay arbitrary element ng O. Okay? Now, by definition of union, yung O sub n ay subset ng O. Okay? For any n element of set of natural numbers. So, sigurado tayo dyan na yung O sub n, kahit ano man yan dito, palaging subset yan ng O. Okay? Then, since yung C ay element ng O, then, yung C na yan ay element din ng O sub n for some n element of the set of natural numbers. So, ang ibig sabihin ko dito, since element to ng O, which is the generalized intersection of O sub n from 1 to infinity, ibig sabihin matatagpuan natin tong C sa kahit isa sa mga elements nito. Pwedeng sa O sub 1, pwedeng sa O sub 2. So, pwede nating makita yung C. Basta isa sa mga yan, or more than one, or pwedeng lahat. Pero ginawa ko na lang ay for some kasi hindi naman tayo sigurado kung saan natin matatagpuan si C. Pero sigurado tayo na yung C ay matatagpuan natin sa O sub n. Okay? Sa set dito. Sa ilang set dyan. Okay? Now, since yung O sub n is open, Kasi nga, ito ay collection of open sets. Countable collection of open sets. Then, there exists an epsilon, positive epsilon, such that the epsilon neighborhood of C is a subset of O sub n, which is yung O sub n ay subset ng O. Okay? Hindi na pala yata kita kanina. Therefore, yung O natin is open. Kasi nakakita tayo ng epsilon, yung epsilon neighborhood ng C ay subset ng O. Okay? So, we are done. Punta naman tayo sa next statement. The intersection of a finite collection of open set is an open set. So, for our proof, so take note ang pinag-uusapan dito ay finite collection of open sets. Okay? So, let the set containing O sub 1, O sub 2, O sub 3, up to O sub n be a finite collection of open sets. Okay? And let O be the intersection of O sub n from 1 to n. Kasi finite intersection of open sets yan. Pinag-uusapan natin, not infinite ha. Then, dapat mapatunayan daw natin na yung O, which is yung finite intersection nga nito, ay open set. Okay? So, we have to show that O is open. So, meron din tayong dalawang cases dyan. So, una, if O is an empty set, then again, O is open. So, sana ganun na lang, no? Tapos na. Pero syempre, i-consider naman natin yung may mga laman. Okay? So, let O be non-empty set. And syempre, kung non-empty set siya, meron siyang element. So, let C be an arbitrary element of O. So, dito, katulad ng kanina, we need to provide an epsilon, positive epsilon, so that yung epsilon neighborhood ng C ay subset ng O. So, ganun yung ginagawa natin no, kapag nagpo-prove tayo ng open set. So, dapat makapag-provide tayo ng epsilon such that yung epsilon neighborhood of C, where C is an arbitrary element of O, must be a subset of O. Okay? Now, since yung C ay element ng O, this implies C element ng intersection of O sub n, n equals 1 to n. Okay, kasi yung O natin, this is the intersection of O sub n from 1 to n. And this implies C element of O sub 1 and C element of O sub 2 and so on, C element of O sub n. Ibig sabihin, element siya ng bawat isa na nasa loob ng set na to. Kasi yun yung definition ng intersection. Okay? Now, since O sub n is open for all n equals 1 to up to n, then may mag-e-exist, nakalimutan ko isulat yun din, then may mag-e-exist na epsilon, let's say epsilon sub 1, epsilon sub 2, up to epsilon sub n, such that yung C ay element ng C minus epsilon sub 1, comma, C plus epsilon sub 2, which is yung epsilon neighborhood ng C para sa O sub 1. Okay? Kasi open set yung O sub 1 eh. Okay? And also, yung C ay element din ng C minus epsilon sub 2, by the way, 1 pala to, C plus epsilon sub 2, which is a subset of O sub 2, and so on, up to C element ng C minus epsilon sub n C plus epsilon sub n sa subset of O sub n. Okay? So, kulang yung papel natin. Tuloy natin. Now, kunin natin yung epsilon. So, take epsilon to be the minimum ng mga epsilon na to. So, minimum ng epsilon sub 1, epsilon sub 2, up to epsilon sub n. Okay? So, ibig sabihin, kung dito, mas maliit yung epsilon. Kumbaga, pinaliit lang natin yung open interval dito sa O sub 1. Dito rin, pinaliit natin yung open interval. Okay? Kung hindi man minimum yung sa O sub 1 yung sa O sub 2. Okay? So, ibig sabihin, eto mas maliit. Sigurado tayo na walang epsilon sub n na mas malaki dito sa epsilon. Kasi siya yung minimum nito. Okay? At kung siya yung minimum, then, yung C ay element ng C minus epsilon, C plus epsilon. Take note ha, pinaliit lang natin yung interval. Okay? Subset ng C minus epsilon sub n, C plus epsilon sub n. Okay? Kasi mas maliit yung interval na to sa kahit anong maliban sa isa siguro. Kasi minimum kumuha tayo ng isa dyan. So, pwedeng sa lahat, mas maliit to, maliban sa isa. Yung isa, equal. But, walang mababago kasi subset naman. Wala namang magiging damage doon. Okay? And this is a subset of O sub n. Okay? For n equals 1, 2, 3 up to n. Okay? This shows that kung itong interval na to ay subset ng O sub n for any values or for any value ng n dito, then yung epsilon neighborhood, which is ito, of C is a subset of O, which is, kasi kahit alin dito subset siya ng O sub n So meaning, yung mga laman na ito ay laman ng intersection ng O sub n. Okay? So, ibig sabihin, yung epsilon neighborhood ay subset ng O. So, therefore, yung O natin is open. So, we are done. Okay? So, hanggang dito lang sa discussion natin for open set.